Okay, so we're going to have a look at some trig, or trigonometry as it's actually known, trigonometry today, and we're going to be looking at missing lengths. Okay, so I have posted another video that goes through missing angles, but today, in this one, I want to focus on missing lengths. Okay, so starting off just over the basics again. Okay, trigonometry works with right angle triangles. The type of trigonometry we're looking at works with right angle triangles. So we're looking at something that uses what we talk about SOHCAHTOA. Okay, so when I've got my right angle triangle, the one opposite the right angle, or the slanted side, is my hypotenuse, which is my longest side. If I've got the angle marked, the one opposite the angle is called the opposite, and the other one is called the adjacent. Okay, and you need those three sides and those three names to help you with this. So let's have a look at a couple of examples and see what happens. Okay, so if I've got a right angle triangle and it wants me to find a missing length. Now, when it wants you to find a missing length, it will give you one of the angles. Okay, it'll give you one of the angles. Okay, and it will ask you to find the missing length x or the missing length whatever it is. So the first thing I do, I label my sides. I've got my hypotenuse. Okay, this one would be the opposite, and then this one would be the adjacent. Okay, and I write out SOHCAHTOA. I like to write them as little triangles because it helps me remember what I'm actually doing. Okay, it tells me sine equals opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent, and I'll show you in a minute where else that can be useful. Okay, so I'm going to look through what I've got. So I start with what I've got. I've got my hypotenuse, so I tick the ones that have hypotenuse. I'm getting rid of that tan, that toa, because it doesn't fit in. I then tick the one that I want to get. Okay, so I want to get my adjacent, so I'm going to use this. Now, I can do this in one of two ways, okay? This cat, I'm trying to find my adjacent. So if I cover up my adjacent, I know that I'm doing cos of the angle times by hypotenuse, okay? Some people really like thinking about that like that. It's a bit like your speed, distance, time triangle, and it really helps. Other people just prefer to actually write it out. So what I'm saying is cos of my angle, I'm going to call my angle theta just so it looks different from my x, equals my adjacent over hypotenuse. So then I say cos of 30 equals x over 12. Now, anyone who's been in my classroom before or anyone who's gone through this, we don't like these fractions on the bottom. Okay, so I want to multiply up. And basically what I then end up with is 12 cos 30 equals x. Okay, and that I can just type into my calculator. So I can just do 12 cos 30. I press equals, I get a lovely number here of 6 root 3. Okay, you might get where it's decimal, things like that. Okay, if I press S to D, it gives me the decimal value. Okay, so it's the same with yours. Your calculator will look slightly different to mine. It might not give you the third answer. So I would have 10.4 centimetres if that's the one I'm looking at. Okay, because I've just rounded it. Now, if we have a look at another one, and we'll look at something slightly different this time, so you can see how these questions might change. These are not drawn accurately, by the way, I'm well aware of that. Okay, so this time starts off all the same. It always starts the same. The first thing you do is you label your sides. Okay, so I've got my hypotenuse. And I've got my opposite. And I know that that one would be my adjacent. I write out SOHCAHTOA. And I start to think about what I'm trying to do. Okay, so I've got my opposite. I tick the ones that include opposite. I'm getting rid of K. I've got to find my hypotenuse. So I tick that one, I get rid of this. So what I've got this so, okay? Now, this is where the whole idea of covering up is quite useful, okay? Because this one gets a little bit more complicated. I want to find my hypotenuse. So if I cover it up, I know I'm doing the opposite divided by sine of the angle, okay? But as you'll see in a minute, when I work through it, it's a little bit more complicated to think about. Some people will love this idea of covering up. It makes it a lot easier. Some people will go, actually, no, I like the written out method. I learnt the written out method, but I find that covering up is quite useful. So I'll show you what happens. So we've got sine. Again, I'm just going to write out theta equals opposite over hypotenuse. So I fill in my values. So I've got sine of 50 equals 6 over x. Now what happens this time is our x, our unknown, is on the bottom of the fraction. So when I multiply up, because again, I still don't want that fraction, okay, I'm going to multiply up. What I end up with is x sine 50, or x times sine 50 equals 6. And I've still not quite got to an answer, okay? But at this point, some of you might realise, actually, this was a times, so I can just divide. So I divide by sine 50. And what I end up with is x equals 6 over sine 50, okay? However, right, I've done 1, 2, 3, 4 steps to get there, okay? If I'm using this cover up, I know immediately, and I can write it down immediately, that it's just going to be 6 over sine 50. If you write that in the exam, if you go straight from doing this to that, that's absolutely fine. Okay, you're not going to get, you're not going to lose marks or anything like that. That's the bit they're looking for. Okay, so then again, once I've got to that stage, I just get my calculator. I'm going to do 6 divided by sine 50. And I end up with 7.83, which makes sense. It's bigger than what I've got at the minute. So x equals 7.83. Okay, now hopefully that will help you with at least the basics. Okay, it obviously can get a little bit trickier. As I said, we can look at ones where there's not right angles, okay, but that's a completely different thing and not something you need to worry about at the minute. But have a go at the tasks. And just keep working hard, keep smiling. Bye.